Hi everyone.
Good afternoon, everyone. How are you? To begin with, just to revise some aspects that today will be important. Please check that both device and YouTube player are in a high volume so that you can hear us correctly and that you listen to everything we say. And if that's okay,
we can start. Yeah, I think we can start. Okay, so first of all, let us introduce ourselves. My name is Francesco. I'm part of the didactic team here at Innovamat. And today I also have Anna with me, who is also part of the didactic team and also a primary school teacher. So today, thank you for coming, first of all. What we wanted to do with you is to give you a little bit of insights into what your children are going to be doing during the school year and how they're going to be studying math specifically. So let's start with today.
What are we going to do today?
I think our goals for today are pretty simple. First of all, I think we would like to let you know a bit more about Innovamat, who we are, what we do, and how we're going to work with your children's school. Then we're going to be talking about how we understand the learning of math, and especially the learning of mathematics in primary education, right, at such a particular age. And then I think we're going to share some of the examples of the activities that your kids will be doing in class so that you have an idea of what to expect.
So prepare yourself because today we are going to do math.
We're going to do math, exactly. Let's do that.
Okay. So, well, just for you to know, we love starting with a question because it's a good way of introducing our project.
Yeah.
And this question is, please remember you as students in school in a math lesson, and remember, how did you learn math?
What do you remember? Yeah,
what do you remember?
I think, I was thinking about it when you asked the question, and I think I remember math classes being very repetitive, you know, always doing the same things. I remember a lot of multiplication tables, you know, I remember learning by heart a lot of stuff, memorizing a lot of stuff. And that's mainly what I remember. What about you, Anna?
In fact, I remember the same as you. I remember a lot of multiplication tables, going at home and memorizing these tables because I was very bad at memorization. But it's true that there are some adults nowadays that they remember math as something
completely
fun,
different,
as a positive aspect. School,
and I think that's really the purpose with which Innovamat was born. We realized that there were a lot of people, a lot of kids that were completely disengaged with math, that felt like math was very repetitive, very distant from reality, and let's also say plainly boring also.
So if you put it in a balance, what happened?
I think most people will agree with this, that math classes were very repetitive, very mechanic. But at Innovamat, we wanted to show that it doesn't have to be that way at all. Math doesn't have to be repetitive. It doesn't have to be mechanic. It's a language of the world that's around us, right? So it's very close to reality. And ultimately, math can be real fun, I would say.
So could we say that one of our targets is trying to change this?
Yeah, exactly. We want our kids to leave primary school and to leave school in general, remembering their math classes as a pleasant moment, as a moment where obviously they learned a lot, but they also had fun doing it, let's say. So that's, let's say, the purpose of Innovamat, but also who we are. Who are we? Let's start from this. What is Innovamat? Because you'll probably be confused. Well, we're a bunch of people, all expert, all passionate about mathematics and all expert in didactics, and also with experience in the classroom, as I said before. And we've developed this proposal to help kids and teachers study and teach math in a more meaningful way. So which way? Let's talk about that. I think there's mainly three principles upon which the proposal was built, right? And the first one is that we believe that learning happens through the kid's own discovery, when the kid discovers things for himself. And that's very important because we don't think learning happens when the kid just repeats something that has seen or has heard from the teacher. No, the kid learns when he does that for himself.
Through experimentation.
Yes, exactly. Experimenting, making mistakes and learning from those mistakes. So that's our first point. Second is that we want to work on the children's mathematical ability. That sounds very fancy, but what does it mean, right? What does it mean to be skillful at mathematics? For us, it doesn't mean to be able to repeat all the multiplication tables by heart. It doesn't mean to be able to do 50 additions in 10 minutes. No.
Yes, it was when I was a student.
Yeah, it was.
Because well, we were also always said like a good mathematic is the one that can make 10 additions in 5
very
minutes.
Fast, and it's always good, like doesn't make mistakes. Not now. We've realized that being skillful at mathematics really means so much more than that, because it means being able to solve problems. It means being able to think, to connect the dots, to make connections, to make hypotheses.
Well, to think, because we weren't used to think in maths. It was very mechanical and we had to like memorize.
Exactly. Whereas right now we've realized that really what we need to be doing is to reason, right? To reason a lot and solve problems. That's what being that's what being skillful at mathematics really means. So that's our second objective, let's say. And last but not least, we do believe that every kid is different, and obviously every kid learns in a different way. So that has to be, it has to be reflected in the classroom as well, right? We believe that learning should be as personalized as possible in order to be meaningful for that specific kid. Now, this sounds very fun, this sounds very interesting, but let's also say that this is not an experiment, absolutely.
Yeah, because sometimes we think that we are like making something that hasn't been done before.
That is completely new, that it hasn't been tested. And the truth is that actually what we do is based on a lot of research. The field of didactics of mathematics and research in didactics of mathematics has been telling us to work this way for a long time now, for years, if not more. And what we do at Innovamat is exactly that. We follow all of the latest trend in didactics of mathematics. We study all of this research that a lot of bodies around the world are producing, and we analyze it and we pass it on to the teachers that work with us. And that is how we work with your children's teachers, essentially, and with your children's school.
Let me throw another question.
We like questions.
Yeah,
we love
questions. We like to interact with you. Next question is, what did you learn in maths? So remember again, you as students in school in the math class, and think about the contents or the knowledge that you learned in the math class.
Yeah.
For example, Francesco, what did you learn? What do you remember?
We've already said before, but I remember a lot of multiplication tables, a lot of them. I remember in general all the operations, let's say. I remember doing a lot of divisions as well. On my notebook, a lot of additions, a lot of subtraction, mostly that, in primary school. But
are you talking about like numbers and operations?
Yeah.
In fact, I also remember the same, and I don't remember, it's true that I remember classes, math classes in which geometry was being built or worked, but in upper grades, not in first grade or second grade.
Maybe, a little bit later during the primary school years, But, well, I think that's something that a lot of people can agree with, because traditionally math teaching is always focused on numbers and operations. We've always worked a lot arithmetics, and sometimes it's important to remember that mathematics is so much more than that. Because mathematics is also geometry, as you said. It's also probability. It's also statistics. Measurement, right. And I know that it sounds like kids in first and second grade cannot do statistics, or at least that's one can think that, but that's absolutely not the case. I mean, they can actually do that.
Well, in fact, in Innovamat, we try that all kids work or study different contents and not only numbers and operations.
Yeah, exactly. I think you've seen the slides before with the different content blocks. Can we put it on as well, Jordi?
Thank you.
So at Innovamat, we want to study all of these content blocks, right? We don't want to focus just on numbers and operations. And in order to do that, we've developed two different dynamics to help teachers in class.
And why two?
Yeah. Well, the first one is called the Number Lab, and the second one is called the Adventures, and you can see which content block is worked, is studied in each of the two. But why, you ask? Well, because obviously numbers and operation is a content block that is particular in its character, in the sense that it's very hierarchical. I cannot multiply if I don't know how to add before.
You have to have like previous steps before.
There's a sequence, right? There's a structure.
A new knowledge.
Whereas all the other content blocks don't really follow a structure, let's say a rigid structure. I can do shapes and I don't know, I can do squares and triangles and circles before I do probability, or vice versa, or measurement. I mean, all of these content blocks allow for much more flexibility, let's say. So we separated the two, but obviously we have to learn all these different aspects, let's say, of mathematics.
So we work them in class, but then we have to practice math, because math has to be practiced.
Math has to be practiced, exactly. And in order to practice, we've developed this app that we call the Innovamat app, that allows kids to work on all of these different content blocks, doing math exercises just like we were used to doing, but with a little twist. And I don't want to make any spoilers yet.
No, we will talk it about later.
Let's talk about the app later, yes. And let's move on to the next thing.
Yeah. So now what it comes to my mind is we have seen what Innovamat do in classroom with our children, but can we see an example about
that? Let's
because
do
it's
some
very difficult to know how do we work this.
Yeah. I think it's much easier if you see an example.
So let's start with an example. About what?
Let's do an example from the Number Lab, I would say. And then we're going to
numbers and operations.
Yeah. So the most traditional part of mathematics, let's say. And this is an example from first grade that we chose today.
Yes.
And it's a very simple question. How much is 8 plus 9?
Should we do it
Let's
on
do
our...
it on
on our whiteboard.
Okay. I think
8 plus 9.
Yeah. And...
Okay. Done.
Okay, so Anna, how much is 8 plus 9?
17.
Okay, great.
Good.
How did you do it? That's what I'm interested in.
Okay, what I've done. For me, it's easier to do 8 plus 8.
Okay.
Because I know it's 16.
Okay.
And because the operation was 8 plus 9 and I'm just done 8 plus 8, I'm missing adding 1.
Okay.
So this equals 17.
Okay. So what you're doing is you already remembered 8 plus 8, you already remembered something, and you use that something as a base to then deduce another result, right?
Yeah, because 8 plus 8 for me is easier, and
it's
because
easy.
it's an operation that I use day to day, so for me it's easier. I have done it like this.
Okay, that's great.
How have you done it?
I've done it in a different way, because what I thought, obviously, I also have 17 here, but what it's easy for me is to pass through the 10. Let me show you. So I have the 8, and what is easy for me is to break down the 9 into two different numbers. 2, because 8 plus 2 is 10, and I think it's a very easy addition, and I can, it comes natural to me. And then I add another 7, which is what's remaining of the 9, right?
Yeah, because 7 plus 2, it's 9.
Exactly.
So you break down 9 into 2 and 7.
Yeah.
And you have, you stopped in 10 because it's more comfortable for you?
Because, it's easier for me to add a number to a 10.
Yes.
Because there's the 0 on the right. I don't really have to count that much. 10 plus 7, I already know it's 17. So that's the easiest way for me.
Okay.
But there's also other ways that kids can discover when they're doing this in first grade. For
do it
example,
here?
yeah, let's try to do it
Yeah.
here. Maybe, okay,
Yeah, like that.
like that, okay. Do we have the other?
Yeah.
Oh, thank you. Okay, so how much did we say? 8. Okay, what I can do is I can imagine a number line, right? I can imagine the numbers placed on a line. I'm at the 8 and I want to add 9 to this 8. So what I can do is to jump 10 units to the right, because it's very easy to add a 10, right? I just
Yeah.
have to add the
With
1 in
18.
front of it. It's 18, I can see that. And then what I do is I subtract 1 unit in order to arrive to my solution. So what I did here is to jump, no, on a hypothetical.
But that's a
number
very
line.
abstract representation.
That's
How
a
do we do
very
it?
abstract representation, yeah. Too abstract for kids that are 6 years old. So what we do instead of painting this number line is we use this beautiful necklace.
Yeah, the bead
right?
necklace.
Exactly.
Yeah, we could put it like that.
That is something that, yeah, kids will be using in their first year, in their first grade. And that is a way to conceptualize this number line in a more practical, easy to understand way, because I can actually touch
In
this. I can
fact,
actually
as
play
you
with
can
this.
see, this bead necklace changes color every 5 units. We start
yeah.
like this because for kids it's more easy to jump by looking at the colors first.
Yeah.
And once they know this material very good and they are understanding that what they are doing is jumping in a line, it's easier to pass to a
Yeah.
more abstract representation.
100%.
That's a very good material. They love it.
Yeah, and very fun as well, as we said before.
Yeah. So that's
Yeah, so
the
those
diversity of strategies.
these are all the strategies, yeah, calculus strategies that we're gonna be working on during the first grade. Now, we're obviously gonna work them in second grade as well. We will absolutely not stop. All of this work continues in second grade. With one addition. In second grade, we also add another strategy, which is called the decomposition strategy. Let's try it to make an example, no, Anna?
Okay.
So
So we work the same strategies that we have already seen
Yeah.
in the whiteboards and in the paper. And now in second grade, we add another one.
Exactly.
Called, how do we call that?
Decomposition.
Decomposition
Decomposing,
strategy.
yeah.
Wow. Okay.
Wow, very fancy names. Obviously, your kids will not use these names, but it's important that they understand what they're doing.
Do you want me to write?
Yeah, sure. So, for example, let's try with 17 plus 15. Okay.
Plus 15.
Yeah. Okay.
Okay. But
So,
as we saw before, there was like a middle
box, yeah.
like a middle step.
yeah.
Yeah, like this.
Yes.
Are you going to show us how? Yeah,
Yeah, let's
okay.
see. Let's see why we use this. Let's see why we put this box in the middle, right? So
How do we start this strategy?
let's start by representing this number. In the classroom, I have this material, like base 10 material, that kids are gonna be used to working with. So they will know how to represent this number. Let's try to represent first a 17 and then a 15.
Do you need units
Yeah,
too?
exactly.
Yeah, it's a material that they have already
Yeah.
discovered that 10 units
Yes.
are 1/10.
Exactly.
So that's why it's easier for them to.
Yeah, each
Decompose.
cube represents 1 unit and each bar represents 10
1/10,
units.
yeah.
So a 10.
10.
Yeah.
So let's start
okay.
with the 17. How do you
Let's
represent
represent
the
it.
17?
So I have 1 bar, so a 10,
10.
and 5, 6, 7. Okay, 7 cubes. Whereas here I have 1, 2, 3,
15,
4.
it's a 10
5.
and 5 units.
Yeah.
So this one we don't need
Yeah,
them.
we don't need this.
Okay.
So how would you start now, Anna? How would you sum this?
I would like what I would do is to get the units and add them together,
Okay. And
and then some like add the 10.
okay, that's one way of doing it, but let's also try in a different way. And let me ask you a question, since we love questions so much. When you go to the supermarket and you have to
Okay.
pay, I don't know, 24 euros or 32 euros, what do you count first? The coins or the notes?
The notes?
The notes, right? We start with the big numbers. So let's try to do the same here, right?
Okay.
Let's try to start from the bars. Here I have 2 bars. So, sorry. What I know that this is a 20, so
Yes,
that's what I can write
20
here.
units.
20 units,
Okay.
exactly. And now I have to count my cubes, which are 4, 7, 10, 12. I have 12 cubes. And so this is what I need the box for, essentially. What I'm doing here, and the name of this strategy as well, comes from the fact that I'm decomposing this addition into one that is much easier and much more transparent for me, that I can understand in an easier
in fact
way.
it is.
Yeah. What we did was to take the tens together, take the units together, and then add the
them.
results in order to get to our final
This
result.
middle step is like
Yeah.
an additional box.
Yeah, exactly.
We always add here.
We'll use it so that kids understand what they're doing better, and
They
that's
understand
exactly
where the result comes from.
They understand where the result comes from, but obviously throughout the year we will start also abandoning this box. At some point we will want our kids to be able to solve this addition without the help.
Doing this step mentally.
Exactly, mentally and without this material.
Fantastic.
Great, yeah,
So
let's
we add
move on.
this in second grade. Fantastic. Now that we have already seen Number Lab, what do you think if we see a challenge?
Yeah, sure.
Let's see adventures. What happens here?
Maybe just one last point about this, because maybe you parents are wondering, okay, I just studied 1 when I was in primary school. Why do my kids need to study 5 different strategies?
Important.
And that's important to understand, because we want our kids to be we want our kids to study all of these different strategies because we want them to be mentally versatile. We want them to be able to use one strategy or the other depending on the context that they're faced with. We want them to have this elasticity, right? To be able to arrive to the same solution but using different paths, using different...
So that they can use the one that is more quick for them, more comfortable. For example, that you use the 10.
I passed through the 10 here.
And I did the
you
right
deduced
facts, the known facts, the right facts.
So that's also very important. I would say let's see an adventure. Let's see a challenge. Okay. We've told you that the adventures is the part of the proposal where we work on all the other content blocks, right? And every adventure is thrown at the kid as a challenge, basically. And there's a brief video that always introduces the challenge and puts it into context. I think
we could say that these challenges are day-to-day challenges.
Yeah.
Things that they can find in every day for them.
So maybe let's watch a video, right?
Okay.
To introduce one adventure.
One of the challenges. Okay. Jordi, can you help us to put the video, please?
Hello, Silver.
Hi, Ada. Where are you going?
We're going on a trip to a nature reserve. I'm going with the biologist Bibby and Fossley to catalog some endangered species.
Wow, how interesting. I'll go with you.
Follow me. There's still a good stretch to go before we get there. If I'm not mistaken, we should reach the river soon, and then we'll be able to cross it with a zip line.
Well, it seems to me that the zip line needs a good dose of problem solving.
What bad luck. The rope tied between the 2 trees is broken. Oh, no. And now? How are we going to get to the nature reserve if we can't cross the river?
I have an idea. Your friend Umberto hasn't arrived yet, and if he's at home, maybe he could help us.
You're right. I'll call him.
Hello?
Umberto, it's Ada. Are you still at home?
Yeah, I was just about to leave for the nature reserve.
Wait, we can't cross the river because the zip line is broken. We were wondering if you had any iron cable in your hardware store. We could try to rebuild it.
Wait, I'll ask my dad. Dad, do we have any iron cable? Iron cable? Yes, of course. Great, I'll put it in my backpack. But will it fit? You'll need to know what length of cable you need. Ask your friend. Oh, right. Ada, are you still there?
Yes.
How much cable do you think we'll need?
Gosh, I'm not sure. How are we gonna figure out the length we need?
Do you want me to lend you a hand? What you need is to know the distance between the two ends of the zip line. Did you hear, kids? Umberto needs Ada and Vivian to measure the distance between the two ends of the zip line so he knows exactly how much cable to bring. One way to measure the distance between the two trees is by using our own body as a unit of measurement. Let's practice it. Would you be able to measure the length of one of the walls of the classroom? Let's go!
Well,
Yeah, that
good
was a
video.
fun video, no? We liked it.
We introduce always kids with the challenge with a video like that, so they love it.
Yeah, I mean, in this case, for example, our characters needed help to measure different objects, right? And specifically, they wanted to measure a wall of the classroom using our body. Should we
Yeah.
try to do that with our
with the
desk that we
table?
have here?
Yeah.
Yeah, let's try, Anna.
One of the suggestions they gave us is like putting like in
Yeah, to
straight contact
straight
with
arms
you.
and yeah. Okay, let's
with
start
all
from
students.
here.
But what happens if I say
Yeah.
we can be in contact giving our hands and
Okay.
it's less students like measuring? Or
Yeah.
in this case, because the table is not such
Exactly,
as big
like-
as a wall in a classroom, if I do it myself, it's just one.
It's just
student.
one, yeah. So what am I seeing here? That depending on the unit of measurement that I use, if I'm like this or if I'm like this, well, obviously the result, the length of the same thing, of this desk, will be different. But why? Is the length changing? No, the unit of measurement is changing, and that's what's important, right? After that, the challenge obviously moves on, and
With lots
here,
of conversation.
Yeah.
With it's a very rich activity.
and here we also prepared you a little page from the notebook that the kids are gonna have. This is an activity that we would plan in a class, and
In fact, in this challenge.
yeah, in this same challenge, we would
Yeah.
ask kids to play with us and find out about this. Let's try. So, can we put the
The
zenithal
zenithal
view?
camera.
Thank you, Jordi.
Thank you.
Okay, so what
is
do I
this
have?
activity asking us?
Yeah, what do I have here? I have 3 different objects: a feather, a lizard, and an insect. And what I need to do is I want to measure all 3 of them using 3 different units of measurement. So the first one that I'm gonna use is my fingers,
Okay.
like this, for example, doing this and this. The second ones are cubes, okay? And the third one is a unit of measurement that I'm gonna let my kids choose. So should we try to
Okay.
measure the first object together, Anna?
Okay. Should we start with the
Yeah, with the
fingers?
fingers. Okay.
So
Vale. Let's do it. Okay, so for example, I'm trying to do, okay, 1, 2, 3, 4, 5. Yeah, 5.5, I would say.
Okay.
For me, with the fingers, the feather is 5.5 fingers long.
should I try?
Yeah, try it.
Should I try? Why? I want to prove this.
Yeah.
Okay.
Okay.
2,
3, 4. Wow, okay.
6.
7,
You
yeah.
did wrong.
Yeah. So
8. 8.5.
Uh-huh.
You did it wrong.
we have different results, right? But let's try to measure it with a different thing. Let's try to measure it with the cubes. Maybe we'll have different results, right? Let's try it.
I'll try it with the green
yeah,
ones.
sure.
You try it with the blue ones.
Yeah. So for me, the feather is exactly 5 cubes long. Yeah.
Okay. Let's try it with the green ones.
Yeah, it's the same, right? It's absolutely the same. So why would I plan an activity like this in class? Like, what do I want my kids to understand here? Well, as you might have guessed from our little game here, we want kids to realize that obviously if I have different units of measurement, I'm gonna have different results. And we've seen that with the finger. Everybody has different fingers, and in a classroom, that's very obvious because there's one adult, the teacher, and all students that are 6, 7 years old. So obviously they have smaller hands, smaller fingers. And in that way, we all have different results. It's impossible to compare the results. It's impossible to have a conversation about it. Whereas if I use this, which is a standard unit of measurement, it's the same for everyone, well, then I always have the same result. And then I can compare my results with other kids and have a discussion about it. And that is why we need, right, a standard unit of measurement. That's what I want my kid to realize. I'm not talking about meter or units of, or let's say, traditional units of measurement yet. I'm just letting him find out why we need to have a common standard, right?
And it is important also that in this activity, what we are doing is encouraging our students to discuss the answer, because there's not a wrong answer in this case, because the unit of measurement is different. So this discussion is very rich because all the knowledge is being built by them. It's not the teacher giving the knowledge and they memorizing or learning it.
They're finding out
by doing. That's very important.
Exactly.
They love challenges. This challenge is very good.
Yeah, I think all of them are very fun. I hope you'll have fun watching that as well.
But that's not the practice.
Yeah, no. Let's talk about practice, right?
I think it's important.
We've told you before. We've told you before that in order to practice systematically, we've developed this app, right? That lets kids play with math exercises. Now, the cool thing about this app, you can see some of the screenshots here. The cool thing about this app is that it adapts to every kid's specific needs. And that's the cool thing about technology, right? What this app does is it detects areas where the kid is not doing so good at, where the kid needs to improve, it's struggling, and it suggests more exercises on that topic to get better at it and improve.
And it's a very gamified application, and that helps them not to see mathematics as repetitive, as we said before.
Exactly. But more like a game, right?
And here is where we individualize this learning.
Exactly, because every kid will do something different. For example, if I'm a kid in 2nd grade and I'm struggling with shapes, for example, well, obviously the app is going to detect it and suggest me more exercises on that. Whereas if I'm very good with shapes, with geometry, and I'm struggling a bit with some of the additions or some other concepts, some other content, well, then obviously the app is gonna suggest me that content to get better at.
And to end with, what do you think? Because I think families have always the same question, and it's important to explain them. No? One of the questions they normally have is, how can I help them at home? Because I want to help them in this math learning, but you do it very different as I did it when I was in school. So it's difficult for me to help them. Do you have any tips or something that can help them?
Sure. Actually, thank you for asking that question, because we know that you guys want to help your kids at home, obviously. So here's a couple of advice that we feel comfortable giving you. I think the first advice that we can give you is to take advantage of the math that's around us and to use it as an excuse to make your children really passionate about math. For example, if you're going to the supermarket, why don't you let them count how much you're spending? Ask them questions. Use all the numbers that are around you. There's a lot. And use that as an excuse to practice math, to make your kid more curious, more ask questions and all of that. I think secondly, another advice would be to ask them what they're doing at school and ask them to explain everything that we've just done.
Yeah.
Because that's actually one of the skills that we want to work on.
You want them to communicate what they have done.
Exactly.
If they need to represent it, do it too.
Exactly. If being able to communicate, to explain what I'm thinking, how I thought of this, and repeat it out loud is one of the skills we want to work on, communicating, right?
Yeah.
And last but not least, you also have these 2-minute videos that are called 2-minute strategies, where we, in 2 minutes, like the word says, let's say we explain a little bit the strategy, the main points about it, and how you can help your kids when you see that they're working on that specific strategy.
You can find these strategies in a link that our colleagues will pass now in
the
through
chat.
the chat. Yeah. You will find the link and you will be directly linked to the strategies.
Yeah. And what else? Well, before leaving, I think it's important. In the chat, you'll also see a type form link. Please make sure, to fill it out. It's a survey to help us understand how we're doing and if we can improve on
and
what
how can we help you
Yeah.
as families. If you have any question, you can leave it. There's a space to leave questions so that we can give a response to these ones, but also our colleagues of the chat. I'm sure
we'll
that
be
they will
answering questions in the chat as well.
So
I think we're done for today.
Thank you everyone for being here, for spending time doing math today.
Yeah.
Hope to see you soon.
Thank you a lot. And exactly, we hope to see you soon for another episode of these. So again, thanks for coming and have a great evening. Yeah.
Bye.
Bye.